All right, so what I just demonstrated was organic bends that are more organic and less geometric and mathematically derived. If you are looking for very specific curves with respect to math, if you want perfect circles or just gradual bends that are mathematical. The two tools that you're going to want to learn are the parts bender and the slip rule. And so I'll demonstrate both of those right now. I guess I'll start with the parts bender. It's one of these tools that is awesome, and it's worth its weight in gold. It costs like $100 from Harbor Freight, and if you use it a lot, it'll just pay for itself infinitely. Obviously, you guys don't have to buy it, but it's a great machine. That said, it's very frustrating when you come to it because there's a lot of parts to it. And if you incorrectly put it together, you'll literally just be spinning your wheels and just ripping your hair out. So try your best to refer to the diagrams that I've tucked into the I-beam here. Two of the ones that you guys are going to want to use regularly are just the typical setup for regular bends using a specific die as a radius, and the sharp angle bend. Okay, so these are going to be used often. So the way that these work, if you guys want to come in a little bit closer, is it's a bird's eye view of this machine, the diagram. So I'm oriented with the machine right now. This part goes off like that. The circle's here. The lever arm is right here. And I can basically follow this diagram to a T exactly what. I'll start with the typical setup for bending stock. So right now I've got the lever arm in the wrong spot. It needs to be right here, right? It pivots at the corner. And I'm just gonna grab a specific size die. It doesn't really matter which one I put in here. I'm gonna bend my stock around that size though. So let's say you wanted a much sharper radius, just put a different size die in here than what you're using. It goes up to 3 inches in diameter. Yeah, even this one, right? So it doesn't matter what size die you put in there, but in this bend setup, whatever you put in there, that's what your rod's gonna be bent around. So keep that in mind. There are two different size pegs. There are 3 pegs with 2 different sizes. There's 2 long ones and a short one, right? The short one goes in a very specific spot, so try to remember that. The long one goes here because it doesn't really move. The other long one will go here. The short one goes in the lever arm because it moves. If you put the long one in there, it'll stick up too far. If you put it in here, it just won't work right. Use the short one in the lever arm. All right, so I've got that set up, and then they've got a pretty big die set up. 1, 2, 3, 4 holes back. 1, 2, 3, 4 holes back, right about there. Put the shorty in there, right? So far, so good. Now they have a stop block, right? They got this guy, and they've got a peg, one of these. What's in there? Some flux, maybe. So I'm going to set my peg there, my stop block here, just like that. Now everybody come and kind of take a look. Does that look correct to you? To what they have set up, for the most part? Okay. Slight modifications to this are okay, but the point is that when I put my rod in, there has to be 3 points of contact, right? The rod's going to, you're fine, Shelby. The rod's going to come up against the stop block. It's going to come up against this roller, and then when I start to bend it around, it's going to come up to here. If you don't have 3 points of contact, you're going to be really frustrated, and you're not going to be able to do anything. So try your best to start with this and then modify as needed. By modify, I mean change out the different size bending form, change out this, or move it, slightly to the back or to the front, depending on what you're doing. The other thing that people get frustrated with is the stop block. You see where the hole is? It's not in the center. That wasn't a mistake. For whatever reason, they figured out the physics on this. The hole has to be on the right side. And by right side, I mean bird's eye view. You see how the hole in the stop block is on the right side, right? So it can be like that. I think it has to be like this for it to work. If you have it incorrectly positioned and the hole's on the left, again, physics-wise, for whatever reason, the rod wants to slide along that stop block as you go around. So if you have a very particular spot that you want to start the bend and it starts to slide, it gets frustrating, right? A way around that, because I've found that even when this is positioned correctly, sometimes the rod will want to slide. You can take some vice grips or some kind of clamp and clamp the rod up against there, so as you start to go around, it doesn't want to move. Does that make sense? Okay. So I'm going to grab, what is it, 3/16? And let's say I want it to bend at a very particular spot. Let's say it's right here, that I want the start of my curve to be, that looks like about 1 inch in diameter. I'm going to set this up here. And I'm going to go far enough that it's pinched in here and it doesn't move. So everybody take a look at this before I start to move. I've got the piece flat on the lever arm, parallel, horizontal. It's up against the stop block, up against my backing roller, and up against the die. And now I'm just going to start bending. And as I go around, obviously this out here, you know, if it's super long, you'll have to kind of dance around it and figure it out. And that's not moving. If I had this turned incorrectly, this would be sliding right now. Yeah. And another thing that can happen, you see how this roller, it's not perfectly pinched in there. If you're bending, say, 1/8 inch, it can slide underneath there. So it might be to your benefit to not be right on here, but come up into space a little bit. The tricky part there is that if your piece isn't perfectly horizontal and it's slightly down, you start to bend and you're gonna bend basically a spiral rather than a perfect curve in the same plane. Does that make sense? I see some nods. I think most of you are getting what I'm saying. The other limitation to a lot of our bends are, that's as far as I go, okay? So maybe some of you are already thinking, well, wait, what if I wanted to go all the way around, right? You have to figure it out. If you want a perfect circle and they're small, my suggestion is to bend a half circle and a half circle, you cut them and weld them together. If you want a tiny little circle, this is the best way to make a half circle and a half circle, but to make a full round piece that you clip and then bend into space, I'm sure people have done it and can do it, but it's just so much easier to bend 2 half circles and weld them together, okay? Oh, I'm locked in here, I can't get this out. What am I gonna do? Oh yeah, this thing just comes apart. I can just take this whole thing apart and it falls apart just that. But it's never locked in there because you can take it apart. So pass that around, check it out. Questions about this?
Is that the largest one we have?
This is, what's that?
Is that the largest one?
It is. This one right here, yeah. 3 inches,
well,
oh, yeah. 3 inches is the largest die that we have for this machine.
That's what I was, do we have a larger one of these machines?
We don't.
Okay.
Yeah. If you want to bend larger circles, you will probably switch to the roll, the slip roll, which I'll show you guys in a minute. That said, the 3-inch die is the largest diameter you can bend using this machine, and supposedly the smallest diameter circle you can bend with this roller is a 4-inch diameter circle. So you could jump from that to that. That said, it gets infinitely more difficult to bend smaller circles with this machine. So I'm going to show you guys how to bend a 12-inch circle, which is very easy, and even smaller circles are fine. But to bend a 4-inch circle, I've never done it with that machine. I've never tried, but it says it I'm pretty sure in the booklet that you can do it. But let's stay with the parts bender for a minute. Any questions about its ability? That was 3/16. It can very easily bend 1/4 inch. And as you get up into thicker and thicker size pieces, it's all, you've got the leverage here and the clamping, and it's no big deal. 3/8, because you've got the leverage here, it takes a little bit more force, but you can bend it, and we can extend the lever arm. If you really want to get crazy on this thing, you can probably bend a 1/2 inch, no problem. But what's that?
It's a touch of force too.
Yeah, yeah. So, yeah. And so here, even though this is set up often for folks that want very specific mathematical curves, you don't have to. I could put this back in as long as it's pinched up against the stop block. and do something a lot more organic like this, you know, pretty quickly I get, and I didn't even mark that off. I just was kind of doing it spontaneously, but it gives, you know, and it's somewhat faceted, but you can see, you know, how you could achieve a curve. Okay, so that's the regular setup for just bending stock. Now the other thing that folks might want to use is the sharp angle bend. So this doesn't pivot off the front hole. It pivots off 1, 2, 3. So here I'm going to go 1, 2, 3. That, I don't know why they even put that in there. Don't even think of that as a hole, because the pegs won't go in there. So just count 1, 2, 3. Do that. It's black. I don't know what that means. I've never been able to figure that out. I'm just guessing that it's just the peg by itself, whereas the 2 circles refers to an actual die like that. And then we've got the sharp angle component here. And the long side goes out, and we also need a peg here to keep it at the right angle. And we're going to count 1, 2, 3. 1, 2, 3 here. All right, so I think that's correct for doing the sharp angle bend. Now instead of inserting your rod this way, you're going to put it in that way. You can see according to the thing here. And again, you're marking where you want the bend to happen. Let's say I want it to happen right there. Now, when I say sharp angle bend, that's about as sharp as you're gonna get 3/16 using this machine, okay? If you want it sharper than that, I would just cut this, weld them together, grind it to a point, right? But thinking about projects where you want a slight curve to it, this might be it. If you want more of a curve, I would put the die in there and do a bend. Questions about this? Okay, awesome. So parts vendor, you're welcome to leave it set up. There's no reason to take it all apart, because the next person will most likely have to change everything anyway. So we can just leave it like this, and we'll put all the pieces that aren't being used currently down here, out of the way. Since we're about to start this next part of the project, usually this stays set up, and the lever arm just gets kind of in here in space. But if you need to take it apart, we can. These typically will live here. This is the explanation of the stop block. I read about it here, and that's another section of the manual. That I've got them out. They're in the filing cabinet where I sit. If you guys ever want to look through the reading material for any of these machines, I got out the slip roll, the bench grinder, and the sander, and the compact parts fender, which now if you buy it, I think it comes as a floor model, but it just made more sense for us to have it as a table model. All right, we can cut the video there.